Good day, I am Gaylorus Conde-Jamero. Today I will present my study on evaluating the effectiveness of oil spill response readiness at the Port of Nisipit, focusing on environmental baselines such as oil and grease and total suspended solids. Even a small oil spill can travel hundreds of meters before a response begins. This highlights the importance of readiness. At the Port of Nisipit, oil spills threaten ecosystems and livelihoods. Our study focuses on improving Tier 1 preparedness. Ports like Nisipit are economic hubs but are also exposed to environmental pressures from residential discharge, fish cage operations, and runoff. These activities may affect water quality and ecosystem health, necessitating improved preparedness for environmental incidents. This study highlights the concept of a sediment trap. When oil interacts with suspended sediments, it forms oil mineral aggregates, or OMA, which causes the oil to sink, complicating surface recovery. Station 5 acts as a sediment trap due to high sediment input. This study has 5 main objectives: to analyze water quality trends, determine the relationship between TSS and oil and grease, evaluate the contingency plan alignment, design a site-specific response protocol, and propose an environmental scorecard. Water samples were collected from selected stations from 2023 to 2025. 8 parameters were analyzed, including DO, BOD, TSS, and salinity. Statistical analysis, such as mean, standard deviation, and correlation, was used to interpret trends. This slide shows the 5 sampling stations across the port. Special attention is given to Station 5, where the oil spill occurred. Data were obtained from PPA monitoring reports, and incident logs were requested through FOI. The results show fluctuations in key physicochemical parameters over the monitoring period. Suspended solids also showed variability, reflecting sediment disturbance within the port area. This figure illustrates the oil and grease trend. Dissolved oxygen decreased in certain periods, indicating reduced water quality, while biochemical oxygen demand increased, suggesting higher pollution. This figure shows the TSS trends. While values fluctuate, they remain relatively high, especially in the inner harbor, indicating persistent sediment influence in the study area. This graph illustrates the relationship between TSS and oil and grease. The results indicate a moderate positive relationship, suggesting that higher sediment levels increase the likelihood of oil mineral aggregate formation. The correlation analysis confirms a moderate positive relationship between total suspended solids and oil and grease concentrations over the monitoring period. This quantitative data supports the hypothesis that the port environment facilitates OMA formation. The observed trends are influenced by human activities such as residential discharge, fish cages, and river runoff. The 2022 oil spill incident further demonstrates that even small spills can significantly impact water quality when the response is delayed. The proximity of intense human activities near the harbor suggests that non-point source pollution contributes to the water quality dynamics. The port is a vital hub for transportation and commerce. Its operations and surrounding activities directly influence water quality parameters. The methodological framework involves 3 phases: gathering baseline data, performing statistical analysis and gap diagnosis, and generating management tools like a training protocol and a joint scorecard for iterative policy refinement. The 2022 Yacht Michaela spill, though small, spread 391 meters due to delayed response. High TSS levels likely aided oil dispersion and aggregation, demonstrating that small spills can have large impacts. The study concludes that while water quality is generally compliant, the interaction between TSS and oil and grease poses risks. Fluctuating TSS levels and increasing oil concentration highlight a growing risk of oil mineral aggregate formation, complicating containment. Recommendations include adopting a context-sensitive Tier 1 response, enhancing PPA-PCG coordination, integrating community welfare, and establishing a PPA-LGU joint environmental scorecard. Effective oil spill response must consider the environmental context, not just operational aspects. This video underscores the need for robust, environmentally aware oil spill readiness protocols. This slide provides the key references supporting the study's findings and recommendations. Thank you for watching this video on ENRM 240 Aquatic Resources.